So Vesa, last time we were together we were talking about the pervasive need for increasing power density, not just in terms of making the components smaller, but really in finding alternative space to put them in so that more of the board area is available for innovative designers to use. We talked about mechanical and thermal constraints, but let's take it a step further. Let's talk about some feature constraints, transient response constraints, and maybe even some thermal AC/DC constraints. Let's talk a little bit about feature constraints. You were telling me more about the stereo equipment.
Well, remember those fancy stereo components that we had stacked up and taking up shelf space in the house? Now the market has consolidated those into a single unit, and now you can carry thousands of songs in your pocket on your smartphone. That's the basic principle behind taking different and multiple features and consolidating them into a single power unit, freeing up board space.
But how does that actually work here?
Well, in a traditional circuit board design, to deliver some features you may need some discrete and separate components to deliver features like accurate output voltage or current measurement, accurate temperature measurement, or tight voltage set point. At GE we've consolidated all of those features with high accuracy into a single power unit, the Giga D-Links, which takes what used to take almost 1,000 square millimeters and reduces it to just 750 square millimeters, providing back 25% of board space to designers.
That's a great example of consolidating features. Let's talk a little bit about transient response. Can you tell us a little bit about that?
Sure. One of the priorities in power conversion is to ensure that output voltage transients during load changes stay steady. This can be managed to an extent by adding external capacitance, but that comes at a cost, both dollars and board space.
So Vesa, what's the right answer here?
With GE's point-of-load models, we improve transient performance with our patented tunable loop technology. By adding a small tuning capacitor and resistor, tunable loop allows achieving target transient performance with much less output capacitance. Tunable loop reduces board space needs by up to 75% and saves material cost by having less output capacitance.
So Raj, I want to talk a little bit about some of the thermal constraints in AC/DC supplies. The fundamental physics are that a power supply will dissipate heat and that heat needs to be removed, and usually that requires a fan. But before digging into the constraint, let's talk a little bit about the CLP product.
Well, Kareem, the CLP0212 is an open frame power supply. It uses zero voltage switching, quasi-redundant topology, and at the same time, we also use higher frequency to reduce the size of the components and the transformers.
So that only gets us so far. How do we go the rest of the way? How do we give space back to designers?
Well, Kareem, we had to rethink the cooling aspect for the power supply. We asked ourselves, rather than spending effort and time in improving the efficiency of the cooling fan, can we completely get rid of the fan?
So no fan at all?
Exactly, no fan at all. We did this by placing the heat-intensive ICs at the bottom of the PCB, the unused negative space. And we were also able to employ the conductive cooling through the chassis.
But how well does that really work?
It worked really well. The original design was for 200 watts. We still got 200 watts, but we were able to shrink the PCB size from 21 cubic inch to 11.2 cubic inch.
Wow, so that's almost half.
Exactly.
So we've covered three really good examples of designing in the negative space. With either feature constraints, transient response constraints, or thermal constraints for AC/DC, we've been able to give back space to designers to innovate it. In the next installment of the series, we'll take it one step further. We'll talk about servers, racks, and cabinets, and how can we apply the same principle to give those engineers the space they need.